In this video, I'll show you how to expand an expression using the binomial theorem. This is part 2 in the series. The question reads, find the first 4 terms of the following expression. Now, unlike before in part 1, where we had a simple expression like a plus b to the power of 5, in our case here, this does not look like the following expression. So what we have to do is rewrite the given expression without radicals or fractions and then expand using the theorem. Let's go ahead and do that. First of all, this cube root of 3 can be written as 1 over a minus 3b to the power of 1 over 3, all powered to 1 over 3. This expression and this expression mathematically mean the same thing. On the same note, we can rewrite this part of the expression so that it has a negative exponent. How do we do that? Well, we can take this part of the expression, the denominator, put it as our numerator of 1 over a minus 3b to the power of a third, all powered to negative 1 over 3. Once again, mathematically, these 3 statements mean the exact same thing. Now we also have this fraction, 1 over a, that can be written as a to the power of negative 1. And we're using the exact same property that I used to go from this to this. What we'll do next is split this negative so that it's plus minus. So instead of having a negative, you have a plus minus, which means the same thing. Plus times minus is still minus. And we're doing that for the sake of making it look like this, where we have a plus in between the two terms. A to the power of negative 1 plus negative 3b to the power of 1 over 3, all powered to negative 1 over 3. So let's start off with the first term. And before we do that, let's define what our n is. N is equal to negative 1 over 3. A is a to the power of negative 1. And b is negative 3b to the power of 1 over 3. Let's go ahead and substitute these values into this formula. Our first term will be a to the power of negative 1 to the power of negative 1 over 3. I'll simplify this in a later stage. Plus n, which is negative 1 over 3. Notice how careful I am here. I don't want to make an error. A to the power of negative 1 to the power of negative 1 over 3 minus 1. And don't forget the b, times negative 3b to the power of a third. So all of this is our second term, and we'll have to reduce this in a later stage. Plus, this is our third term now. We have negative 1 over 3 times negative 1 over 3 minus 1 over 2 factorial. Once again, a is a to the power of negative 1, and the power of this is negative 1 over 3 minus 2 times our b term, which is negative 3b and a third to the power of 2. Our last term is defined as this expression, and I've cut out a piece of the formula above and placed it here for simplicity. My n is negative 1 over 3 times negative 1 over 3 minus 1 times negative 1 over 3 minus 2 over 3 factorial times my a term, a to the power of negative 1 to the power of negative 1 over 3 minus 3 multiply 2 negative 3b to the power of a third. And don't forget the power of 3. The task ahead of us is the complicated part. Now we have to simplify each of these terms. And because this is an ongoing binomial, I'll have to write down plus and this ellipsis. So a to the power of negative 1 to the power of negative 1 over 3, we have to use the power of a power rule for the laws of exponents. We multiply these two and we end up with a to the power of positive 1 over 3. Plus, now let's figure this one out. We have negative 1 over 3 minus 1 times negative 1. This gives us 4 over 3. So negative 1 over 3, this part hasn't changed, times a to the power of 4 over 3 And this part stays the way it is. Notice that I have a 3 here, and a 3 here, and a -1, and this -1. This leaves us with plus a to the power of 4 over 3, b to the power of 1 over 3. Now that I've cleaned this up a little bit more, I can move on to the third term. Let's find out the answer to this in our calculator. We have -1 over 3 times -1 over 3 minus 1. And I'll put this part in brackets just in case our calculator confuses what we're asking it. Divided by 2 factorial, which is 2, that gives us 2 over 9. So all of this becomes 2 over 9. Let's find out what that is equal to. -1 over 3 minus 2. Using the power of a power rule, so I'll multiply this by -1, and that gives me a to the power of 7 over 3. Finally, this part simplifies to -3 to the power of 2, which is positive 9, and b to the power of a third to the power of 2 is b to the power of 2 over 3. The 9's cancel out, leaving us with the final expression shown here. Finally, our last term consists of all of this, and I'll use my calculator to evaluate the first portion. You should end up with -14 over 81. Let's find out what this is equal to. A to the power of -1 over 3 minus 3 times -1 gives us positive 10 over 3. And this part is missing a 3. So 3 to the power of a third is 1. -3 to the power of 3 is -27. We have a negative and a negative. That becomes a positive. And 27 divided by 81 is simply a third. So this becomes a 3, and this goes away. Now since this is ongoing, we write down plus and these 3 dots. And there you have it. That is how to expand an expression using the binomial theorem.